Welcome to Glad Labs podcast. Today's episode, Beyond the Basics, Unlocking Fast API's Hidden Potential with zhanymkanov / fastapi-best-practices. Fast API has quickly become a popular choice for developers building application programming interfaces or APIs, and with good reason. Its speed, ease of use, and automatic data validation, powered by Python type hints, are all very compelling. The official tutorial provides a great starting point, but scaling a fast API application beyond a simple example requires adopting established best practices. Many developers encounter roadblocks as complexity increases, issues with code organization, testability, and maintainability. That's where resources like the zhanymkanov / fastapi-best-practices GitHub project become incredibly valuable. This project isn't a library you install. It's a carefully curated collection of patterns and approaches designed to address the challenges of building robust, scalable, fast API applications. It represents a distillation of experience, offering practical solutions to common problems that many teams encounter. The project demonstrates a deep understanding of how to effectively utilize fast API's features, particularly its dependency injection system, to create clean, modular code. The community around Fast API on GitHub is very active, and this project truly reflects that collaborative spirit. Let's now turn to the challenge of maintaining a clean architecture as your application grows. It's easy to create a monolithic codebase where everything is tightly coupled. The zhanymkanov / fastapi-best-practices project highlights the importance of separating concerns and adopting a layered architecture. This often involves structuring your application into modules based on functionality, separate modules for authentication, data access, business logic, and API endpoints, for example. This approach isn't unique to Fast API. It's a principle of good software design applicable to any framework. However, Fast API's dependency injection system makes it particularly well-suited to this pattern. Dependencies, such as database connections or external service clients, can be defined as reusable components and injected into your API routes and business logic functions. This promotes loose coupling, making your code easier to test, maintain, and extend. Consider a scenario where you need to switch from a Postgres database to a different data store. With a well-designed dependency injection system, you can simply swap out the database dependency without modifying your core business logic. This aligns with the principles outlined in the Fast API documentation, which emphasizes modularity and testability. Fast API's dependency injection system is a powerful feature that is often underutilized. It allows you to define reusable components that provide dependencies to your API routes. These dependencies can be simple values, complex objects, or even asynchronous functions. The zhanymkanov / fastapi-best-practices project demonstrates how to use dependency injection effectively to manage resources like database connections, authentication tokens, and external API clients. A common mistake is to create dependencies directly within your API routes. This tightly couples your code and makes it difficult to test. Instead, define dependencies as separate functions and inject them into your routes. This allows you to easily mock dependencies during testing and swap them out for different environments. For example, you might have a get_db dependency that returns a database connection. During testing, you can replace this dependency with a mock database connection that returns predefined data. This approach significantly simplifies your tests and ensures that your API is reliable. Many organizations have found that investing time in setting up a robust dependency injection system pays dividends in the long run, reducing maintenance costs and improving code quality. Building a fast API is only half the battle. Ensuring its reliability requires a comprehensive testing strategy. The zhanymkanov / fastapi-best-practices project emphasizes the importance of unit tests, integration tests, and end-to-end tests. Unit tests verify the correctness of individual components, while integration tests ensure that different parts of your application work together correctly. End-to-end tests simulate real user interactions to validate the entire system. PyTest is the standard for testing Python applications, and Fast API integrates seamlessly with it. You can use PyTest to write tests that verify the behavior of your API routes, dependencies, and business logic. A key aspect of effective testing is to use mocking to isolate your code from external dependencies. This allows you to test your code in a controlled environment without relying on external services. For instance, if your API interacts with a third-party API, you can mock the API response to ensure that your code handles different scenarios correctly. The project's examples often showcase how to write tests that cover edge cases and error conditions, ensuring that your API is resilient to unexpected input. Users frequently share custom testing setups and strategies on GitHub. fastapi is built on top of Starlet and Pydantic, both of which are designed for asynchronous programming. This means that fastapi can handle a large number of concurrent requests without blocking, resulting in significantly improved performance. However, many developers are not familiar with asynchronous programming and struggle to take full advantage of fastapi's capabilities. The zhanymkanov/fastapi-best-practices project provides guidance on how to write asynchronous code that is both efficient and easy to understand. Understanding async and await is crucial. When you call an asynchronous function, you use the await keyword to pause execution until the function completes. This allows other tasks to run while the function is waiting for a resource, such as a database query or a network request. However, it's important to avoid blocking operations in your asynchronous code. For example, if you need to perform a CPU-intensive task, you should run it in a separate thread or process to avoid blocking the event loop. The zhanymkanov/fastapi-best-practices project is a living document, constantly evolving as the fastapi ecosystem matures. The best way to learn is to explore the project's examples, experiment with the patterns, and contribute your own ideas. Start by cloning the repository and running the example applications. Pay attention to how the code is structured, how dependencies are managed, and how tests are written. Don't be afraid to experiment with different approaches and see what works best for your specific needs. And if you find a bug or have a suggestion for improvement, feel free to submit a pull request. By contributing to the community, you can help to make fastapi even better for everyone. Consider also exploring the broader fastapi ecosystem. Libraries like SQL Model for database interaction and tools like Docker and Docker Compose for deployment. Thanks for listening to GladLabs podcast. Visit gladlabs.io for more episodes, articles, and insights.
See you next time.